Hello there. Today we will be talking about the important advancements of the atomic theory. These contributions will date back all the way from 1960 to present. First we will talk about the field ion microscope, then the Standard Model, then the quark theory, the modern theory of weak interactions, and lastly the theoretical Higgs boson and Higgs field theory. The field ion microscope uses neon as an image gas instead of helium. The ion microscope introduced image intensification. It works by using a sharp metal tip, which can be used to show an arrangement of atoms, allowing the viewer to perceive the object or organism that is being observed as larger and more obvious compared to a standard microscope.
The atomic theory of matter is the Standard Model theory. The Standard Model theory is a current understanding of the laws of nature. Universally, there are four main forces. These forces include gravitation, electromagnetism, strong nuclear forces, and weak nuclear forces. Gravitation is the force of gravity. Electromagnetism is what helps form our atmosphere and will protect us from solar radiation. Strong nuclear forces that will bind the atomic nuclei together, and weak nuclear forces govern hydrogen fusion, which is the source of the sun's energy, and beta decay, which is when a neutron breaks down, changing into a proton, emitting an electron and an antineutrino. The Standard Model talks about three of these four forces, those being electromagnetism, strong nuclear forces, and weak nuclear forces. The Standard Model theory states that there are three main particle groups that make up everything, and one theoretical particle that exists in none of these groups. The three main particle groups are the quark group, the lepton group, and the gauge boson group. Leptons can be separated into two types, those that are electrically charged and those that are not. The electrically charged ones are the muon, the electron, and the tauon. The neutral ones are the muon neutrino, the
The
electron
quark
neutrino,
theory
and the
states that
tauon
quarks
neutrino.
can be
The gauge
positive
boson
or
group
negative.
includes W
Three
bosons,
types of
Z
positive quarks
bosons,
are
gluons,
up,
and
charm,
photons.
and top. Three types of negative quarks are down, strange, and bottom. Originally, the top and bottom quarks were going to be named truth and beauty. However, this idea has been changed. An example of matter made up of quarks is a proton. A proton is composed of two up quarks, one down quark, and gluons
The modern
that
theory
mediate the
of weak
forces binding
interactions
them
suggests
together.
W and Z boson particles interact with electrons, neutrinos, quarks, and other particles. These bosons are similar to photons, but there are some serious differences. For instance, the photon has very little mass, only having 10 to the negative 30th power of the mass of an electron. The Z and W bosons, however, have 80 times the mass of an electron. When trying to model the Z and W bosons, scientists were missing a particle that they couldn't find. This particle, some scientists believe, is the Higgs boson, which the Higgs boson and Higgs field theory. This theory elaborates on the Higgs boson, which emits a field, which is called the Higgs field, which is believed by scientists to be the reason that all matter has mass. If this were to be true, it would make the Higgs boson the single most important particle in all.
From 1960 to present day, there have been several contributions to the atomic theory, those of which presented vastly important information that make up the atomic theory of matter today. In this video, we have brought you four notable contributions, those being the Standard Model theory, quark theory, the modern theory of weak interactions, and the Higgs boson and Higgs field theory. And hopefully, this video has expanded your horizon and knowledge on the atomic theory of matter and its history.